Alright class, welcome to science at Physical Science at Pickway Valley. We're going to be looking at lesson 2.3, Balanced and Unbalanced Forces. If you might remember from Newton's second law, we talked about tug of war, where we had an example of that. And so I want to ask you, and I want you to remind yourself of the things that we did there. When both people in the tug of war were pulling and it was the same amount of force, did the rope move? And if not, I wonder why that is. But when there was one force that was greater, maybe there was something that was stronger, what happened to the rope as a result? I want you to think about that, and this will help us to understand the idea of balanced and unbalanced forces. As you know, forces occur all the time. They could cause things to be pushed, pulled, increase in speed and acceleration, decrease in speed, or decelerate, change in direction, get smashed, or stretch as a result. And so these are some very common forces that are always occurring on Earth. One of which we know very fondly of is gravity. What goes up must come down, and it's basically the forces that are attracting two objects together. So we are attracted to the Earth. As a result, when we try to jump up, we get pulled down as a result. And also friction, the resistance to motion. So friction is another force that we always see occurring. Whenever there is a force, there is that force resisting it on surfaces and also in fluids and air. So whenever I'm talking about forces and I'm calculating them, I'm always going to talk to them as about a net force. And so the total combination of forces acting on an object is called the net force. Sometimes they will be working together, other times they will be working in opposing directions, and you will either add or subtract as such. The rest of this lesson will discuss on when applied forces are acting, things are balanced, and also what the net force will be when things are unbalanced. One instance you will see is that you will see forces working together, and so oftentimes we see this, if you have to move something and you're having someone help you carry something, the forces are working together in the same direction. So the forces are called applied forces. These are forces acting in the same direction. And what we do is we simply add them together. And so when we have these two people moving a sofa at the force of one person at the force of 10 newtons, and then another moving at the similar force of 10 newtons, we simply add those together, and we would get 10 plus 10, and that the resulting net force would be 20 newtons. And the direction would be, in our case right now, we don't have a certain direction, and so it's going to the right, or if we were looking at cardinal directions, that would be east. Sometimes forces are acting against each other, which is oftentimes when there is one force, there is an equal and opposite force. This is Newton's third law. Sometimes those forces are of equal magnitude. If you can remember from the tug of war instance where one person was pulling with the exact same force as the other, as a result, no motion occurred. And so if we take a look at this picture of two people pushing a box, where one person is pushing at a force of 50 newtons, the other person is pushing back with a magnitude of 50 newtons. As a result, those people are pushing against each other with the same force, so they are the net force would be the difference between the two. So when we have 50 minus 50 newtons, the answer is 0. So there is no net force that is occurring. As a result, no motion. That box will not move. Other times, however, we have two forces where one force is greater than another, and as a result, motion occurs. So I look here at this unbalanced example here, where one team is losing in tug of war, or the soccer ball is being kicked in that direction. We see unbalanced forces. If I look back down at this example, there's 50 newtons pushing in the westerly direction, whereas there's a resistance of 5 newtons going against it. The result is that the octagon will move west with a force of 45 newtons because I have to subtract to find what is called the net force. So let's take a look at the examples at the bottom of your notes page. We have two examples of unbalanced forces here. We need to first identify whether or not they're balanced or not, and then identify what is the magnitude of the net force and in what direction it will be traveling. So we have two people here. We're going to work on this example on the left first. We have two people pulling and each other, and so we have one force going at 180 newtons, another one at 140. So first, are they equal or not? I see that one is greater, so they are unbalanced, so motion will occur. And so I need to do a subtraction problem, 180 minus 140, and I get a net force of 40 newtons. And so objects will always move in the direction of the greater force. Since this force is pulling greater, they are going to be traveling west at 40 newtons. Let's take a look at this other example. I have a person riding a bike, and he's riding the bike with a force of 90 newtons and a wind resistance of 5 newtons going in the direction against him. As a result, we also have unbalanced forces. And so we subtract 90 minus 5, and I get a net force, total force, of 85 newtons, and he is traveling again west. And so these are examples of how unbalanced and balanced forces affect the motion of objects.